In the previous video, we have defined the fundamental node class that we can use for representing each and every node that we have inside a single linked list class, right? In this video, let's try to define the similar class that we will use for representing the single linked list as well as for adding all the functionalities that we need to have inside any linked list class. So when I explained you the terminologies that we have inside the single linked list class, right? So I clearly mentioned the very first node we have inside the single linked list class, we will call it as a head node, and the very last node we will call it as a tail node of a linked list, right? So in the linked list that we are going to implement, specifically the single linked list that we are going to implement, it is very important that we have the access to the head node. Once we have the access to the head node, right, this is of type node that we have defined earlier, right? So in this node class we will have the value and we will also have the reference to the next node. So using that next node, from the node 10 we will be able to go to the node code. Similarly, from the node code we will be able to go to the node true. Similarly, likewise, we will be able to reach the very last node, that is false. Once we reach the last node false, at the last node the next pointer that we are maintaining is basically empty, using which we will be able to say we have reached the end of the singly linked list. So here our aim in the process of representing the singly linked list, right, we have to have the access to the head node for sure. So our primary criteria that we should have inside the class that we are going to define will be head pointer should always be there, okay, and it should always point to the first node we have inside the singly linked list. And the second thing is, as part of implementing some of the functionalities such as push functionality, where we try to add the new value at the end of the singly linked list, at that point of time, if we have the access to the tail node, right, we will be able to add that new node very easily. If we don't have access to the tail node, right, first our implementation would be requiring you to go to the very last node. After going to that last node, we will be able to add the new node there. That's why, to reduce that functionality, and what exactly we will do is we will maintain one more value called tail inside the single linked list representation. So just you have to remember that the tail node reference that we are maintaining inside the single linked list, we are trying to use it in such a way that it will reduce the complexities involved in some of the operations that we implement later on. That is something that you have to keep it in your mind. And inside the tail variable that we are going to define, we will always keep the reference of the last node in that variable. Besides these two variables, right, obviously head is the first node and tail is the last node. So besides this, some of the common functionalities that we implement are insert, remove, and get and set are some of the functionalities that we will have inside the single linked list, right? While implementing these functionalities, what exactly we will do is we will try to take the index from the user. So the index, based on the value that user is passing, we will try to perform that specific operation. At this point of time, you don't have to worry, but you just have to remember that just like the operations that we have in the array, where we take the index and we try to update or insert a new value at those indexes, we will try to perform the similar operations in the case of single linked list as well. So to make sure that user, whatever the value that we are taking from the user, if it is falling in the valid range or not, we will also try to maintain the length of the singly linked list as well. So just like how tail that we are maintaining, that is making the process of implementing some functionality easier, the process of keeping track of length also will definitely help us in implementing some of the functionalities very simply. If we don't have the access to the length, right, first our job would be to our job would require us to start at the head node and traverse till the tail node, and then find the length of the linked list and use that length for implementing the functionalities. This will basically increase the time complexity. So to make sure that we are bringing the time complexity down, we will also make sure we are maintaining the length of the singly linked list as well inside our implementation. So these three variables we are maintaining inside the class that we are going to define for representing the singly linked list class. So for class representation, what exactly we will do is we will define a class called singly linked list. Okay, inside this linked list, what we will do, we will define three variables. One will be head. Remember that this head should always point the first node of the singly linked list, and each and every node is of type node that we have already defined previously, right? So we have to make sure that the node type objects are getting assigned to this. Okay, similarly after head we will also maintain the tail node. Similarly in the tail node we will always make sure whatever the operation that we are trying to perform, we will make sure that always the last node reference is available inside the tail. Similarly, this just like how we are maintaining in the head node, the object of the tail node will also be exactly of type node that we have defined. And along with this we will define one variable which will basically contain integer values, since length is an integer, right? In this length we will maintain the length of the singly linked list. Once we define that empty singly linked list class, right, what exactly we will do is we will try to add the no argument constructor. So inside that constructor, at the time of object creation, obviously we don't have any values inside the singly linked list, right? Basically it is empty. To represent that empty state, what exactly we will do is inside the no argument constructor, whatever the head variable that we have defined, right, head variable we will assign it with null. Similarly, we at the time of object creation, obviously there are no values inside the singly linked list, right? Similarly, the tail node also we will assign it with null. And since the singly linked list is empty, obviously length of the singly linked list will be 0. So we will make sure that inside the no argument constructor that we are defining, we will make sure that to represent the empty state of the singly linked list, we will assign the values like this. Okay, so that is what theoretical representation of a singly linked list class. Now let's go ahead and let's write it programmatically. So inside the singly linked list folder, I'm going to create a new file called singly linked list.js. Okay, here what I will do, I'll simply create a class called singly linked list. Okay, so if you remember the discussion that we had clearly, right, there are three variables that we are trying to store as part of the singly linked list implementation that we are doing. One is head node, which is nothing but the very first node inside the singly linked list, and we are also trying to store the tail node, which is nothing but the very last node inside the singly linked list. Along with that, at any point if we want to know how many number of nodes are available inside the singly linked list that we have, we are trying to store the length. So based on that, let me create a constructor so that we will be able to capture those three values. Here what I will do, to store the head node of the singly linked list, I'm going to create a variable called head, and I will be assigning null to it, because when we are trying to create a singly linked list object, at that point there are no nodes inside that singly linked list. That means it is empty. So to represent it is empty, I'm simply going to store head and tail to null. So similarly, like we have head, I will also create one variable called tail, which basically holds the reference of the very last node we have in the singly linked list. In the beginning, since the singly linked list is empty, I will also assign null to tail value. Along with that, we want the length, right? So to hold the length of the singly linked list, I'm going to create a variable called length, and I will be assigning 0 to it in the beginning, because we don't have any values in the singly linked list implementation. Okay, so this is how we actually represent the singly linked list in the beginning. To validate the singly linked list class that we have written here, let's simply try to initiate the singly linked list object and see if we have valid null values in the head and tail and 0 in the length, so that we are 100% sure that we have created an empty singly linked list. So now what I will do, I'll simply create a const sll equal to new singly linked list. Now I'll simply log console.log of sll.head, which will basically give the head pointer in the singly linked list, and console.log sll.tail, which will basically give the last node, which is tail. Similarly, let's simply log the console.log sll.length, which will basically give the number of nodes we have in this singly linked list. So if I simply execute this file, we have written this file inside the singly linked list folder, right? So the command will be node singly linked list, file name will be singly linked list.js. So if I execute, if you observe here, we have null and 0. So this is the proof that we have actually created a empty singly linked list in the beginning when we initiated the object. In the later videos, we will be performing different types of operations on the singly linked list class that we have created based on the individual definitions those functionalities have, and we will also be playing with this head and tail and length so that we have a valid singly linked list where head variable that we have defined here will be pointing to the very first node in the singly linked list, and tail node will point to the very last node in the singly linked list, and length will basically give us the total number of nodes we have in the implementation of singly linked list that we are doing. Okay, so I will see you in those individual implementations. That's all there is for this video right now. Okay, thanks for watching. I'll see you in those implementations.